Hello students, how are you all? So welcome to this lecture, one probability. So we will discuss NCERT exercise 14.1. Okay, so this is disclaimer. So we will cover NCERT exercise 14.1. So let's see first question, question number 1. So read the question, what we have given and what we have to do. Okay, so let's see. So our die is rolled. So we let here E be the event. So the event E denote die shows 4. And if be the event, and if denote die shows even number. So now we have to check E and F are mutually exclusive or not. Okay. So students, try it yourself first. So for showing mutually exclusive, what you need? So for showing mutually exclusive, you need intersection of E and F is empty. Okay. So if E intersection F is non-empty, then E and F are not mutually exclusive. So students, try it yourself first. So you have 30 seconds to try to solve this question, and then we will provide the solution. Okay. So now we will see how to solve this question. So here event E denote the number 4. Okay. And F denote even number. Okay. So then are E and F mutually exclusive? So when a die is rolled, so what is the sample space when a die is rolled? So we know well the sample space of a die when it is rolled is basically S equal to set 1, 2, 3, 4, 5, 6. So the sample space containing the elements 1, 2, 3, 4, 5, 6. Clear? And accordingly, E event is showing number 4. Okay. So the event E is basically equal to singleton set 4. And then if be the event, die shows even number. Okay. So if event is nothing but set 2, 4, 6. Clear? So event is singleton set 4 and event F is containing 2, 4, 6. And you can easily calculate it E and F, intersection of E and F. Okay. So what is intersection of E and F? So E intersection F is basically equal to singleton set 4. Okay. Why? Because you can see here the element 4 is common in event E and event F. Okay. So the intersection of event E and F is basically equal to singleton set 4. And forming mutually exclusive events. So if E and F are mutually exclusive event, then their intersection should be empty set. But we observed E intersection F is singleton set 4 and E intersection F is not equal to 5. Okay. So therefore, E and F are not mutually exclusive events. Clear? So E and F events are not mutually exclusive events. So I hope it is clear to all of you. So now let us move to the next question. So now look at question number 2. So first of all, read the question very carefully. Okay. So read the question. What we have given here, a die is thrown. Okay. A die is thrown. Now describe the following events. So event A denotes a number less than 7. Okay. So A denotes a event where we are taking as an outcome a number which is less than 7. Okay. And then in second we have event B. So event B denotes a number greater than 7. Greater than 7. Okay. And event C denotes a number which is multiple of 3. And the event D denotes a number less than 4. And event E describes an even number greater than 4. Okay. And if event F describes a number not less than 3. Okay. Then we have to find A union B. Okay. A union B, also we call A or B. Okay. And A intersection B, we also call A and B. B union C, and E intersection F, D intersection E, A difference C, D difference E, and E intersection F complement. And also we have to find F complement. Okay. So students, find union of A and B, intersection of A and B, union of B and C, intersection of E and F, intersection of D and E, and difference of A and C. Okay. And difference of D and E, and intersection of E and F complement and F complement. Okay. Find it. So students, you have 40 seconds to try to solve this question, and then we will provide the solution. Okay, students, now we will solve this question. So when a die is thrown, so then the corresponding sample space is given by S equal to set 1, 2, 3, 4, 5, 6. Okay. So sample space contains the elements 1, 2, 3, 4, 5, and 6. If we thrown a die. Okay. And accordingly, what is event A? So event A describes a number less than 7. Okay. So event A is nothing but set 1, 2, 3, 4, 5, 6. Okay. So 1, 2, 3, 4, 5, 6. These numbers is less than 7. Okay. So 1 to 6, all these numbers is containing in event A. Okay. So event A is nothing but the sample space S. And what is event B? So event B describes a number greater than 7. Okay. So but when a die is thrown, then in sample space we have the numbers 1, 2, 3, 4, 5, 6. Okay. So there is no number which is greater than 7. Okay. So the event B is empty set. Okay. The event B is basically empty set. That is also called impossible event that we have studied in our previous class. Okay. So B equal to 5, and this is impossible event. And now event C. So event C containing all those number which is a multiple of 3. Okay. So find multiple of 3 in sample space S. Okay. So here you will get two numbers, 3 and 6. Okay. So 3 is multiple of 3 and 6 is also multiple of 3. Okay. So C containing 3 and 6. These two numbers. Okay. So even C is nothing but set 3 comma 6. And then even D. So even D, okay, contains all those numbers which is less than 4. Okay. So which number are less than 4? Okay. So fine. Here are 1, 2, 3. These 3 numbers are less than 4. Okay. So the even D is set 1, 2, 3. Clear? And then even E. So even E containing all those number which is an even number and greater than 4. Okay. So there is in sample space is only one element, that is 6. Okay. So 6, this number is an even number, also greater than 4. Okay. So even E is nothing but singleton set 6. And now what is even F? Even F containing all those number where a number not less than 4, not less than 3. Okay. So you will get 3, 4, 5, 6, these numbers, which numbers are not less than 3. Okay. So the even F containing 3, 4, 5, 6, these numbers. Clear? So we found even A, B, C, D, E and F. Okay. And now we have defined A union B, A intersection B, B union C, E intersection F, D intersection E, A difference C, D difference E, and E intersection F complement and F complement. Okay, clear? So now we will find these union, intersection, okay, difference, complement of okay. So let's calculate that. So we have to find this A union B, intersection B, and so on. So A union B. So what is the definition of A union B? So A union B means we will take those number, okay, those number which is in A or in B or in both. Okay. So we already found even A. So even A is nothing but the set 1, 2, 3, 4, 5, 6. Okay. And even B is empty. Okay, empty set. So even so now A union B is nothing but the set 1, 2, 3, 4, 5, 6 A union empty set. Clear? And this is equal to basically set 1, 2, 3, 4, 5, 6. So A union B containing 1, 2, 3, 4, 5, 6. These numbers. Clear? And now A intersection B. So what is the definition of A intersection B? So A intersection B means we will take those number which is in A and also in B. Okay. So intersection A intersection B is set 1, 2, 3, 4, 5, 6 intersection empty set. Okay. So we know if we have a set A, okay, and if we take intersection with empty set, then as a result we get empty set. Okay. So A intersection B, this is equal to empty set. Clear? Now B union C. So B is empty set and C is basically 3, 6. Okay. So 5 union 3, 6 is basically 3, 6. Okay. So B union C containing 3 and 6. These two numbers from sample spaces. And now E intersection F. So E is singleton set 6. Okay. And F is set 3, 4, 5, 6. And here you can see 6 is in E and also in F. So E intersection F is singleton 6. Okay, singleton set 6. Now we will find D intersection E. So D is set 1, 2, 3 and E is singleton set 6. Okay, so D intersection C E is what? So you can observe here there is no number which is common in D and also in E. Okay, so what is the intersection of D intersection E? So D intersection E is nothing but empty set. Okay, so D intersection E is empty. Now D difference E. So how we can calculate difference of two sets? Okay, so for calculating difference of the event D and E, so we take that numbers which is in D but not in E. Okay, so difference D difference E, this is equal to set 1 to 3, difference 6. Okay, singleton set 6, and this is equal to set 1 comma 2 comma 3. Okay, so D difference E containing 1 2 3, and now A difference C is equal to set 1 2 3 4 5 6 minus set 3 comma 6. Okay, so we delete here 3 and 6, these two numbers from first set. Okay, 1 2 3 4 5 6. So this is equal to set 1 2 4 5. So A difference C is equal to set 1 comma 2 comma 4 comma 5. And what is complement of event? So complement of event is nothing but difference of sample space and F. Okay, so A's difference F is nothing but complement of F. Okay, so now F complement is nothing but set 1 2 3 4 5 6 difference set 3 4 5 6. Okay, so this is equal to set 1 comma 2. So F complement equal to set 1 comma 2. Clear? So now easily you can find E intersection F complement. Okay, so E intersection F complement, this is equal to singleton set 6 intersection set 1 comma 2. Okay, and you can see here there is no common element in E and F complement. So E intersection F complement is empty set. Clear? So I hope it is clear to all of you. So now let us move on to the next question. So look at question number 3. So first of all, read the question very carefully. So what we have given here, so an experiment involves rolling a pair of dice and recording the numbers that come up. Okay. So now describe the following events. So A event describes the sum is greater than 8. Okay. And B denotes the event 2 occurs on either die. Okay. And C denotes the event the sum is at least 7 and a multiple of 3. Okay. So now we have to find which pairs of these events are mutually exclusive. Okay. So by checking intersection of AB, AC and BC, we have to find which pairs of these events are mutually exclusive. Okay, students. So first of all, try it yourself. So you have 40 seconds to try to solve this question, and then we will provide the solution. Okay, students, your time is over. So now we will solve this question. So we have given here 3 events, okay, and we have to describe the following events, and we have to check which pairs of these events are mutually exclusive. Okay. So when a pair of dice is rolled, then what is the sample space? So the sample space is given by S equal to set of say S containing the ordered pairs x comma y such that x and y equal to 1 to 6. Okay. So you can easily write the order pair which is containing in sample space S. That is here shown in this. Okay. So here you can easily write the sample space S like this. Okay. So this is the corresponding sample space of the random experiment when a pair of dice is rolled. So here you can see A is basically the sum is greater than 8. B is 2 occurs on either die, and C event denote the sum is at least 7 and a multiple of 3. Okay. So now find accordingly. So the event A denotes those number event A containing all those numbers where the sum of the numbers is greater than 8. Okay. So easily you can write event A like this 3 comma 6 4 comma 5 4 comma 6 5 comma 4 5 comma 5 5 comma 6 6 comma 3 6 comma 4 6 comma 5 and 6 comma 6. Okay. So you can verify by adding the first and second number in the ordered pairs. Okay. So values you will get sum is greater than 8. Okay. And event B denote the event where 2 occurs on either die. Okay. Either first die or second die. Okay. So event B representing the set of order pairs 2 comma 1 2 comma 2 2 comma 3 2 comma 4 2 comma 5 2 comma 6 1 comma 2 1 and 3 comma 2 4 comma 2 and 5 comma 2 and 6 comma 2. Okay. And event C denotes denote the event where the sum of the numbers of the ordered pair is at least 7 and a multiple of 3. Okay. So the event C containing all those ordered pairs where sum is at least 7. Okay. So C containing the ordered pairs 3 comma 6 4 comma 5 5 comma 4 6 comma 3 and 6 comma 6. Clear? So now try to observe A intersection B. Okay. So you can observe in event A and B. So there is no common order pair in event A and B. Okay. So intersection of the event A and B is empty set. So A intersection B is empty. And similarly, you can find B intersection C. So in B and C, there is no common order pair. Okay, so B intersection C is also empty. And now calculate C intersection A. So C intersection A. So you will get 3 6 4 5 5 4 6 3 6 6. Okay, these order pairs which are in common in event A and also in C. Okay, so C intersection A is order pair of set of order pairs 3 comma 6 4 comma 5 5 comma 4 6 comma 3 and 6 comma 6. Okay, So C intersection is non-empty. So here you can easily see here are A and B, okay, events A and B, and events B and C are mutually exclusive. But events A and C are not mutually exclusive. Okay, so hence events A and B are events, and B and C are mutually exclusive events. Okay, so we obtain here two pairs of these events which are mutually exclusive. There are A comma B and B comma C. Okay, these two pairs are mutually exclusive. So I hope it is clear to all of you. So now let us move to the next question. So now look at question number 4. So read the question very carefully and then try to solve this question. So what we have given in this question? First see. So 3 coins are tossed once. Okay. So 3 coins are tossed at a time. And let here A denote the event 3 heads. So, okay. And B denote the event 2 heads and 1 tail. So, and C denote the event 3 tails. So, okay. And D denote the event a head shows on the first coin. So now which events are mutually exclusive? Which events are simple event? And which events are compound event? Okay, we have to check this. So students, first of all, try it yourself and answer it in chat section. So you have 40 seconds to try to solve this question and then we will provide the solution. I think you tried to solve this question. So now we will solve this question together. So when 3 coins are tossed, then what is the corresponding sample space? So when 3 coins are tossed, then the sample space is given by is equal to is containing the elements HHH, HHT, HTH, HTT, THH, THT, and TTH, and TTT. Okay. So this is our corresponding sample space when 3 coins are tossed. And accordingly, here the A event denote the event 3 heads. So what is the event A describes? So event A describes set HHH. Okay. And event B denote the event 2 heads and 1 tail. So okay. So event B describes the set HHT, HTH, THH. Okay. So event B containing HHT, HTH, and THH. And event C denote the event 3 tails. So okay. So event C describes the set containing TTT. And event D denote the event a head shows on the first coin. Okay. So event D containing HHH, HHT, HTH, and HTT. Okay. So this sample point containing event D now we will check which events are mutually exclusive, okay, and which events are simple event and which events are compound event. So let's try to find which events are mutually exclusive. So we now observe that A intersection B. Okay. So if we take intersection of event A and B, then what sample point we will get? So you can observe that there is no common sample point in event A and B. Okay, you can easily see here there is no common sample point between A and B. So A intersection B is equal to empty set phi. Clear? And similarly, A intersection C is also phi, because you can see here there is no common element in A and C. Okay, so A intersection C is empty set. And now calculate A intersection D. So here you can see H, H, H. This sample point is common in event A and in also event D. Okay, so A intersection D is equal to basically set H, H, H. So A intersection D is non-empty set. Clear? And B intersection C. So if you find B intersection C, then you will not get any point in B intersection C. Okay, so B intersection C is empty set. And what is B intersection D? So if you find B intersection D, then you will get common point in B and D. So B intersection D is non-empty. Clear? So and now C intersection D is basically no, empty set. Okay, there is no common point in C and D. So C intersection D is empty set. So here you can see event A and B. Okay, and event A and C, and event B and C, and even C and D are all mutually exclusive. Okay, since A intersection B is empty. Okay, so A and B are disjoint sets. So A and B the events are mutually exclusive, and since A intersection C is empty, okay, and so event A and C are mutually exclusive event, and since we have shown B intersection C is also empty set, okay, and also we have shown C intersection D is empty set. So AB, AC, and BD and CD are all mutually exclusive events. Okay, clear? Now, which events are simple event? So, what is the definition of simple event? So, we have studied about simple event in our previous class. Okay, so try to recall what is simple event. Okay, so if an event has only one sample point of a sample space, then this event is called simple event. Okay, so simple event has only one sample point. Okay, clear? So now let's check which event has only one sample point. Okay, so if we get that event where only one sample point, okay, so then that events are called simple event. So easily you can see A and C have only one sample point of a sample space. Okay, so A and C have only one sample point of a sample space. So A and C are simple events. Clear? So A and C are simple events. Now check which events are compound event. So what's the definition of compound event? If an event has more than one sample point of a sample space, then it is called a compound event. Okay, so let's check which events have more than one sample point of a sample space. Okay, so easily you can find, so event B and D have more than one sample point of a sample space. Okay. So thus B and D are compound events. Clear? So I hope it is clear to all of you. So now let us move to the next question. So now look at question number 5. So read the question very carefully first. Okay. So what we have given in this question? So we have given here 3 coins are tossed. Okay. And now describe the following events. 2 events which are mutually exclusive. Second, 3 events which are mutually exclusive and exhaustive. Okay. And 2 events which are not mutually exclusive. And the event, okay, for 2 events which are mutually exclusive but not exhaustive. And 5, 3 events which are mutually exclusive but not exhaustive. Okay. So students, find, okay, that events which are mutually exclusive, okay, and 3 events which are mutually exclusive and exhaustive, and 2 events which are not mutually exclusive, and 2 events which are mutually exclusive but not exhaustive, okay, and 3 events which are mutually exclusive but not exhaustive. Okay. So I hope you all know the definition of exhaustive events. Okay. So try it yourself first. You have 40 seconds to try to solve this question, and then we will discuss the solution of this question. Okay, students, now we will solve this question. So when 3 coins are tossed, then the corresponding sample space is given by S equal to set HHH, HHT, HTH, HTT, THH, THT, TTH, TTT. Okay. So that case is containing these sample point. And 2 events that are mutually exclusive, okay, can be event that getting no heads, and event B that is such that getting no tails. Okay. So this is because you can see the event A is nothing but set TTT, and event B is nothing but set HHH. Okay. And A and B, these 2 events are disjoint. That means A intersection B is empty set. So 2 events that are mutually exclusive can be A equal to TTT and B equal to HHH. Okay. Now 3 events that are mutually exclusive and exhaustive can. Okay. So take the event A such that getting no heads. So the event A describes set TTT, and event B getting exactly 1 head. So event B describes the set HTT, THT, TTH. And C getting at least 2 heads. Okay. So the C is event C denotes the set HHH, HHT, HTH, and THH. So now you can check intersection between A and B, A and C, and B and C. Okay. So A intersection B, B intersection C, and C intersection A is empty. Okay. So here these events are mutually exclusive event. And now if we take union of A, B, and C, then you will get sample space S. Okay, so A union B union C is equal to sample space S. So now find 2 events that are not mutually exclusive can be. Okay, So let's try to find two events that are not mutually exclusive. So take event A, such that getting three heads. Okay. So event A describes the set HHH, and event B describes basically denotes getting at least two heads. Okay. So event B describes the set HHH, HHT, HTH, THH. Okay. Now check A intersection B. So here you can see A intersection B is set HHH. Okay, HHH contains in A and also in B. So A intersection B is non-empty. So this is because we take here two events that are not mutually exclusive can be A equal to set HHH and B equal to HHH, comma HHT, H, comma HTH, comma THH. Okay. Now, two events which are mutually exclusive but not exhaustive. Okay, can be. So take event A such that getting exactly one head. So A event can be right like this: set HTT, comma THT, comma TTH. And even take event B such that getting exactly one tail. So event B describes the set HHT, HTH, and TH. Okay. And why we have taken even A and B like this. So this is because A intersection B is empty, but A union B not equal to A's. Okay. So these two events are mutually exclusive but not exhaustive. Okay. Now three events that are mutually exclusive but not exhaustive can be uh, take even A like this, getting exactly three hits. Okay, so even A is said HHH, and take even B, getting one head and two tails. Okay, so even B containing the sample point HTT, THT, and TTH, and take even C such that getting one tail and two heads. Okay, so C containing the sample point HHT, HTH, and THH. And why we have taken ABC like this? So this is because A intersection B and B intersection C and C intersection all are equal to empty set. Okay, but A union B union C does not equal to C. It does not equal to S. Okay, you can check it. So three events that are mutually exclusive but not exhaustive. Okay, can be like this. So I hope it is clear to all of you. So now let us move to the next question. So now look at question number 6. So read the question very carefully first. So we have given here two dice are thrown. The events A, B, and C are as follows. The event A is taking like this, getting an even number on the first die. Okay, and the event B such that getting an odd number on the first die, and event C such that getting the sum of the numbers on the dice is less than equal to 5. Okay, now describe the events A complement, not B, A or B, A and B, A but not C, B or C, B and C, and A intersection B complement, intersection C complement. Okay, so students, first of all, try it yourself. You have 40 seconds to try to solve this question, and then we will solve this question. Okay, students, now we will solve this question. So when two dice are thrown, then the corresponding sample space is given by. So S containing the order pairs x comma y such that x and y equal to 1 2 3 4 5 6. Okay, so the sample space is containing all those order pairs x comma y where x and y is equal to 1 to 6. Okay, so you can easily construct the sample space is like this. Okay, so these order pairs will contain in sample space is. Okay, so write down the sample space is when two dice are thrown. So now accordingly, okay, given even, so the events A, B, and C are as follows. A basically getting an even number on the first die. So the even A getting an even number on the first die. So even A can be described as the set of order pairs 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 4, 1, 4, 2, 4, 3, 4, 4, and 4, 5, 4, 6, and 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. Okay, so all those order pairs containing in event A. Clear? Now, event B is as follows, getting an odd number on the first die. So the event B containing the order pairs 1, 2, 1, 2, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Okay, and 3, 1, 2, 3, 6, 5, 1, 2, 5, 6. Okay, so all those order pairs will construct the event B. Okay, so you can easily write this. So here getting an odd number on the first die. So we take here 1, 1, 1, 1. Okay, 2. We cannot take 2. Okay, here 2 is not a odd. Okay, odd number. So what is A complement? So A complement is nothing but where the order pair which is not in event A but in sample space. Okay, so outside of event A you will get these order pairs. Okay, so the set containing these order pairs is nothing but complement of event A. Clear? And now node B. Okay, node B means node B is nothing but B complement. Okay, so node B. So node B is basically set containing all those order pairs 2, 1, 2, 2, 2, 3, 2, 4. Okay, 2, 5, 2, 6, 4, 1, 4, 2, 4, 3, up to 4, 6. Okay, 6, 1, 6, 2, 2, up to 6, 6. Okay, and this is nothing but the event A. So the node B event is nothing but the event A. Now A or B. A or B means A union B. So we will take those order pairs which is in either event A or in B or in both. Okay, so you will get these order pairs which are in event A or B. Okay, so you can easily find it. So here you can see A union B is nothing but the sample space is. Okay, so A union B is equal to sample space is. So all those order pairs are containing in A union B, which are containing in sample space is. Now A and B means A intersection B. So you cannot find any sample point which is in event A and also in event B. Okay, so there is no sample point in both A and B. So A intersection B is empty set. and A but not C. A but not C means A different C. Okay, so we will take those order pairs which is in even A but not in C. Okay, then you will easily find these order pairs which are in even A but not in even C. Okay, so this set is basically nothing but A different C. That means also A but not C. And B or C. B or C means B union C. Okay, so we will take those order pairs which are in even B or in even C or in both even B and C. Okay, so you can easily collect those order pairs which are in either B or in C or in both. Okay, so you will get these order pairs which are in B or C. Clear? So B or C is nothing but this set of these order pairs. And B and C means B intersection C. Okay, so we will take the common sample point of B and C. Okay, so 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 3 comma 1 and 3 comma 2. These order pairs are in common in event B and event C. Okay, so even B intersection C is nothing but the set of these order pairs. And C complement. C complement means C complement means which is not in C but in sample spaces. Okay, so if we collect those order pairs which is not in C but in sample space, then you will get these order pairs. Clear? And now you can find A intersection B complement, A intersection C complement. Okay, and we have already shown B complement is nothing but event A. Okay, so A intersection A intersection C complement. Okay, and A intersection A is nothing but A, so A intersection C complement. This is basically equal to A intersection C complement. Okay, and A intersection C complement is basically this set of order pairs 2 comma 4, 2 comma 5, 2 comma 6, 4 comma 2, 4 comma 3, 4 comma 4, 4 comma 5, 4 comma 6, 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 4, 6 comma 5 and 6 comma 6. These order pairs are in A intersection C complement. Okay, so I hope it is clear to all of you. So look at question number 7. So this question number 7, first of all, read the question very carefully. Okay, and try to understand what we have given and what we have to do. Okay, so read the question, and this question is basically homework for all of you. So do this exercise as a homework. So that's all for today's lecture. So thank you very much to all of you.